Hi, welcome to my presentation on AI for Growth. I'm Suzette Young, a doctoral student in the Human Capital Development Program at the University of Southern Mississippi. Here I'm presenting a proposed quasi-experimental research study on one way that AI may be implemented into talent development strategies in organizations. The proposed study will investigate the impact of a machine learning powered skills matching app on employees' perceived organizational support across remote, hybrid, and on site work locations over time. In today's volatile, uncertain, complex, and ambiguous business environments, retaining talent has become a critical challenge for organizations. The pandemic was a stark example of VUCA, highlighting the need for innovative ways to support workforces. During this period, many businesses felt compelled to repurpose existing technologies to manage talent effectively. Skills matching initiatives were already being discussed pre COVID, but the pandemic acted as a catalyst for many companies to evolve into skills based organizations. AI powered technologies have shown promise in enhancing talent management by delivering personalized L&D experiences. As a result, employees may feel well supported by their organization and connected to its mission. Human capital literature emphasizes the importance of reskilling and upskilling employees and promoting internal mobility to maintain employee engagement and reduce turnover. Understanding the impact of tech on perceptions of support is important. There's more to learn about distributed workforces and AI powered tools, and researchers should add to our knowledge on how AI technologies facilitate talent development. This study seeks to answer two questions. First and foremost, does employee interaction with an ML powered skills matching application affect employees' perceived organizational support? Secondly, does the pre to post treatment change in perceived organizational support vary by employees' work location arrangement, being remote, hybrid, or on site? This study hypothesizes that employee participation in the ML powered skills matching web application will significantly increase employees' perceived organizational support over time. Remote, hybrid, and on site workers will show significantly different pre to post intervention increases in perceived organizational support. Remote workers will show the greatest post intervention increase in POS. On site workers will show the lowest post intervention increase in POS. This study is supported by three theories from research literature: human capital resource theory, self determination theory, and organizational support theory. This diagram shows the conceptual framework. This study aims to examine how an ML powered skills matching application can support employee development, namely enhancing perceived organizational support. The results will provide insights into the potential differential impacts of such technologies across various work environments. The study employs a quasi-experimental interrupted time series design. This design compares data across time, focusing on changes in the dependent variable perceived organizational support in response to the treatment employee interaction with a skills matching web app, powered by interpretable machine learning techniques. The ITS design enhances the traditional pre-test post-test quasi-experimental approach by including multiple observations before and after the treatment, providing a more credible estimate of the treatment effect. The population consists of the corporate and administrative staff of a healthcare organization in the southeast U.S., totaling around 14,000 staff members. A stratified random sampling method will be used to select participants from remote, hybrid, and on site work arrangements, ensuring proportional representation. Inclusion criteria will be used as well, some of which will help determine that participants actually interacted with the web app over the course of the study. The web app is designed specifically for the healthcare organization studied here. The underlying machine learning takes into account a large skills taxonomy database developed by researchers and consultants. Also, the app is designed with the user in mind, incorporating interactive visualizations and transparency reports. The DV POS will be measured using Eisenberger's 8 item validated form of the Survey of Perceived Organizational Support. A covariate, attitudes towards technology, will be measured pre treatment and assessed using a 5 item validated Likert scale. Data will be collected over 38 weeks with 3 pre treatment and 3 post treatment observations. Surveys will be administered online to employee email accounts at consistent intervals, with pre treatment surveys sent out every 6 weeks and post treatment surveys starting at week 24. Given the real world setting of this study, participants will have 2 weeks to complete each survey. The app will show them reminders about open surveys. This structured approach ensures robust comparison of trends before and after the implementation of the skills matching application. The data will be analyzed using multi-level modeling, which is suitable for analyzing nested data structures. The model will include level 1 for repeated measures of POS, level 2 for individual level covariates, and level 3 for the group level effect. For Lanyap, Pearson's R will be used to assess the relationship between post-treatment POS measurements and both perceived ease of using the application and Net Promoter Score, variables expected to converge with POS. This analysis will be done as a model validation check in support of construct validity. I hope you enjoyed hearing this breakdown of my proposed quasi-experimental study. Thanks for watching.